we were discussing about the binary search function or binary search procedure. So, here we can see that binary search is of type integer, is a function of type integer that will be returning an integer, and it has got the parameters, the list or the array which is being designated as x here, the size of the array and the key. Now, if the key appears, say the array is here, the array is this or the list is this is called x, and it starts with 0 and the last one is therefore whatever is the size minus 1. So, if the key, there is a key, and if the key appears anywhere here, it will return the position of the point where the key is. If this be the position, that will be returned. Okay. And if not found, it will return minus 1. So, either it will find the send the position, so that is also an integer, or minus 1, hence the type is integer. All right. Now, we have got two pointers, one is L, the left pointer, I mean left index and the right index of this, and from there we are finding out the middle. So, we are finding out the midpoint by this line. Now, if the key is smaller than the middle element, if the key is smaller than this middle element, then obviously our search will be on this side. Therefore, this R will be moved to this point, L will remain here and my search will be restricted in this zone. Otherwise, L will be moved here, R will not be disturbed and the search will be restricted to this zone. This much has been achieved by this piece of code. What else do we need? What else do we need to do? Now, how long will this go on? How long will this go on? So, in this way what will happen is, I will move either L or R, either this or this, and when will this be completed? How long will this loop go on? If you think a little bit, you will find that it will go on as long as L and R are not crossing over. So, if I shift and search this part, R is here, suppose so I initially start with L to be minus 1 and R to be the size. So, I am shifting from, so here is my array and L, value of L is minus 1. So, it is here and R is equal to size, that means pointing here, size plus 1, that means sorry, this point is size minus 1. So, that is actually here, and while as I shift L and I shift between this part etcetera, then I shift L, R is here, but as soon as L and R crosses over, if R moves on this side, then also L and R can cross over. If they cross over, then that is my point where I should stop. So, I initialize this, so and I go on shifting this depending on either L or R. That is exactly what we are doing when we took the say 1, 2, 5, 7, 9, 13 like that, 15. So, I started with the middle number, and when the key was, suppose my key is 16, all right, or say okay, let me erase this. My key is say 12. Suppose my key is 12. What will happen? My L is here, this is L, this is R. I start with mid is 7, So, key is greater than this. So, I will have to restrict my search in this zone. I take the middle of this. So, R becomes this becomes the R, and I am sorry, R remains the same. I have to search between this zone. So, what I do, I shift L, I have to search between this zone. So, I shift L to this. So, this is my new L and this is R. I have to search in between this. I find this to be the mid, fine, and I find that the key is less than the mid. So, I will restrict my search within this zone, within this zone, right, since it is less. So, then what should I do? If since I am moving on this zone, I will shift R, keeping L fixed, I will shift R here. So, this will be R now. Now, between this L and R, I find mid, this is my mid. Okay. I find 9 to be less than 12, that means it should be on this side. So, I move L. As I move L, L is crossing R. That means, now I have come to a position where I have exhausted everything and I could not find the key. All right. So, if L is greater than 0 and XL is equal to key, L is greater than or equal to 0 and XL is the key, then I return the pointer, otherwise return -1. So, that is the binary search algorithm. Okay. This is how I am carrying out the algorithm through a C code. So, here is an example. I am writing down an array, suppose I am writing down a sorted array, suppose it is -17, -5, 3, 6, 12, 21, 45, 63 and 50. 63, it cannot be 50. Say this one is, say this up to 63, that is my array. Now, if I carry out, so the size is 1, 2, 3, 4, 5, 6, 7, 8, I must have another one. So, let me have 75. And if 3 be my key, this is the key. So, what will happen? I will start L here, R here, and I will find the midpoint here. So, the midpoint will be here 12, and 12 is greater than the key. So, my search will be within this zone. So, this R will be shifted here. So, this is now my R and this is L. I will find out the midpoint 3 here. Now, as soon as I come to this mid and I find that this mid is matching the key, my search is found. All right, I get my key in a particular position. So, you can write it in different ways. So, in this way, if I do that, then I will get different results. So, -17 I just missed out, -5, 3, 6, 12, 21, 45, 63 and 75. So, if for this my L was at -1, R was at 9 and my mid was this x 4 12. Okay. So, then x 1 is -5, I carry on doing this, L is still 1, R is 4, R has been shifted to here, and x 2 is 3, I have found it. So, that is my result. In that way I will carry out, and you can find out that L and R, and then I return L. I go on shifting. So, that is what it has happened. I have got the mid value and I have got the value, but then still I am going on shifting. You can also, what I was suggesting is, it is also possible to check the equality with the x mid. As soon as I find that the element has matched with the mid, then it is found. I think you have understood it. You can try writing out the algorithm yourself. This is a binary search. We will see later that it can be also done through recursion. Now, why are you doing so much? Earlier linear search was very much simple, right? Here, suppose we had 1000 elements. If we had 1000 elements, then an ordinary search, if a key is a member of X, it would on an average it would have required 500 comparisons on an average. But what will happen in the case of binary search? After the first compare, 1000 elements. So, we are left with only 500 elements, because I started with an array, and then based on that I have either gone on this half of the array or this half of the array, depending on whether the key is less than or greater than the mid point. This is the mid. So, on an average, first compare I am left with 500 elements, next compare, this part is again divided. If it is on this side, I am left with 250 elements, right. After at most 10 steps we are done. In that way I go on dividing it, and after at most 10 steps I am done. So, I had 1000 elements. Okay. So, I can, so in that way I get 250 elements, then 125, then half of that 60, 65 or something like that. In that way, number of steps that I will be following will be around 10. In general, if there are n elements in the array, the number of searches required is 2 to the power k should be n, where k is the number of steps. Okay. For n, if there be 64, initially the list is the size is 64. After first comparison, the list is 32. After second, it is 16, then 8, then 4, then 2, and then 1. So, 6 steps. So, basically at every step I am breaking it down into half. Therefore, if I need the k steps, then if I need k steps, then 2 to the power k should be equal to n. That means, how many steps are there? How many? What is k? If I take log, then k log k, k log 2 is equal to n. Therefore, k will be log 2 n to the base of log 2. Okay. So, log 2 log 64 to the base 2 is 6. So, we will be completing in 6 steps, whereas in the worst case I would have needed 64 comparisons in the case of linear search. Now, given this idea of binary search. So, what have we seen? We have seen binary search is a search algorithm that enables us to search for an element much faster than linear search. The approach being that we divide the array to be searched in half, okay, every time. So, we divide it into half and restrict our search in half, and in the next step I further divide it to half and restrict it to even a smaller step. So, every time I am halving whatever array I am checking. So, 2 raised to the power k times I halved it, where k times I have halved it, 2 raised to the power k should cover the entire n, and so from there we get the complexity to be of log 2 log n to the base 2, log n to the base 2. In general, it will be log, if 64 is replaced with n, it should be log n to the base 2, that is my time complexity compared to. So, I can say this order of log n to the base 2 compared to order of n, that was the case in the case of linear search. Okay. Now, we will move to another very fundamental problem in programming. We often need that. See, for example, here we have done one thing, that is, I had an array like say 2, 3, 7, 6, 1, 9. Now, this was an array on which I cannot run binary search. Why I cannot run binary search? Because binary search can be run only on sorted array. So, if I sort it either in increasing or decreasing order, say for example, it becomes 1, 2, 3, 6, 7, 9. This is a sorted array, or the other thing could be 9, 7, 6, 3, 2, 1. This is also a sorted array in the other direction. It is descending order, this is ascending order. Okay. So, now another problem is to arrange the things, arrange the objects. Suppose there are number of numbers like this. You have to arrange them sorted or arranged in a particular way. The question is how to do sorting, how to sort. So, suppose I have given this array to my program, this is the input. Then if I want to apply binary search, then I cannot directly apply binary search on this. So, what I can do, I can first take the array, say I read the array, let me write. Then sort the array and then read key, apply binary search. Now, binary search takes for n number of elements, it will be faster. But how do we sort the array? So, it is faster than linear search, but is it advisable to approach in this way? If the array is not sorted, is it advisable to sort the array and then apply binary search? In order to understand this, we have to first see how an array can be sorted, how an array can be arranged in either increasing or decreasing order. That is also a very important problem, that is called the sorting problem. And this has got a very important application in many objects. Whenever I for example, you have got the marks of the students, all right. You have got a marks array, say you have got 2-dimensional matrix maybe, where all right, let us take one-dimensional array, where the roll numbers are here, every row is corresponding to a roll number, and here I think I'll just do it again. I have got the marks here 56, 50, 65, 70, etc., etc., etc. Now, I want to find what is the highest marks. One thing is that I can find that out, or I want to attribute ranks first, second, third, like that. In that case, I can sort this array, and from here I want to have an array like this, where the first element will be 70, second element will be 65, then 56, then 50. This is also sorting the marks in a decreasing order, and along with that I can also sort the roll numbers and can publish which roll number got what marks, right. So, what we want to see next is sorting. Let us define the basic problem first. Sorting means given an array like 0 to some size minus 1, reorder the entries so that they are in this way, that x 1 is greater than equal to x 0, x 2 is greater than equal to x 1. So, if it be this, sorry, why is this greater than equal to coming up? Say for example, 2, 5, 5, 6, 6, 7, 9, this is also a sorted array. So, both these elements could have taken any order, but since they are same, they can be assumed to be sorted. That is why this greater than equal to thing that is coming up. Okay. The list here it is in non-decreasing order, non-decreasing. I cannot say increasing order because it is not increasing 2, 2, 5, 5, 6, 6, 7. So, here of course, there was an increase, but here there is no increase. So, this is rather instead of calling it increasing order, we can call it non-decreasing order. We can also sort a list of elements in non-increasing order, it is non-decreasing order. So, I can also sort it in the other way as we had shown earlier. Okay. So, here is an example, this is sorted in non-decreasing order, you can see this array 10, 30. Now, this is the original list. Now, if I sort them in non-decreasing order, it will be 10, minus 10, 10, 20, 30, 40, 60, 70, 70, 270s, 80. And if I do it in a non-increasing order, then minus 80, 70, 70 in this way. This is not increasing in this way. Here it is not increasing, all right. Here it is not decreasing if I go in this direction. So, these are the two possibilities. So, the sorting problem is if we have an array from 0 to size minus 1, I want to sort it and get a sorted list, all right. That is what I want to have. So, the first algorithm that we will be talking about is selection sort. Selection sort is something like this, that suppose we have got a list here and this part of the array is already sorted. This part of the array is sorted in a non-decreasing order. This already the smallest element is here, the smallest element may be minus 10, then 10, then 20. This part is somehow has been sorted. Now, I am left with sorting this part only, this remainder. What should I do? I am going to select the candidate for this position, right. I am going to select the candidate for this position. For that, what shall I do? I will start, since this part is sorted, all the elements on this side are either equal to this or less than this. So, I will have to look at this part and find out the minimum element that is here. This element, that is minimum, since this part is sorted, this element must be greater than these elements. So, among these, only for these people, this one is the smallest. So, I select that and put it in this position. I swap. How do I do that? Suppose here it was minus 10, 10, 20, 30, and here it was 50, this point, this part is sorted, 50, 32, 72, 31. Now, I remember this position and search from here and find out the minimum. The minimum is 31. So, this 31 comes, I swap it here. So, what happens to my array? This part, let us see what it will happen. It will now become, from here it was 30, it will be 31, 32, 72, 50. So, up to this part it is sorted now. Now, from here I will try to find out the minimum element. I find this is the minimum element and I sort out the minimum element. I swap this minimum element with itself. So, up to this is sorted. Now, out of these, now I have to find out the candidate for this position. So, I find out the minimum, I come here and swap this. So, it becomes 50, 72. So, here in this selection sort, the approach is that we are going position by position and I am selecting the element that belongs to that particular position. So, whenever I am starting with the search, then at the beginning I am starting with the, if this be my array, then I am first searching for this position and this position will be the minimum of all these. I search all through here and find the minimum. Suppose the minimum minus 10 was here. So, I take and bring this minus 10 here. So, it becomes minus 10. I know this is the minimum. Now, I am sorting, I am now looking for this position. I select the element, minimum element in this zone. I find here something 10. So, this part is done. So, now 10 is swapped here. So, 10, 10 and then this part is unsorted, this part I will sort. In this way we go on. This is one of the sorting approaches. We will deal with it further in the next lecture.